Give me a minute, I'll make this fast. Our Balance-O-Homelock 3000 is here at last. There's nothing like a good old fancy home lock to protect your home. To install, and the lovely color complements your nails.
But how do you do it?
Well, good question, lonely peasant. Once the lock is set and you try to open it, you have to solve a chemical equation first. And there are 3,000 different types of chemical equations. Isn't that amazing? Chemist, biologist, and magician Penny Marco will teach you how to solve these different types of equations.
Chemist, biologist, and magician Penny Marco. Today we're going to learn how to balance equations.
Oh wait, no. Oh no, no. Oh, I didn't mean swap. Alright, now we're even. No, that's
okay.
fine.
Do it already, So to begin, what you gotta know about equations is there's 4 types.
Yeah.
4. The first type is synthesis.
We're filming tomorrow.
If you know anything about the English language, you would know that syn means to.
It just said those
something like that. So it's like A
wait, no, but I feel like I'm
plus B is your fine. The second type
Is there another compound with
decomposition. If you know anything about the English language, you would know.
We're gonna get really creative then.
Means to take apart or break apart. C plus B. If you know anything, and if you see, they're low-key the opposites of each other. They are the opposites. Single replacement, which basically means so basically, because one of them's always alone, okay, and final one is double replacement, which is AB plus CD equals AD plus, oh, that's an arrow, plus CD.
We have double replacement, which is AB plus CD equals AB plus CD. AB are made up by cations and anions. Cation of the first one matches up with the anion of the second one, and then the anion of the first one matches up with the cation of the second one, switching places in both of the elements.
So the easiest way I've taught my students how to balance equations is first by listing the elements that we have in our equation. The only 2 we have here is iron and chlorine. So what we're going to do is we're going to count how many irons we have on this side of the equation, on the reactant side, which we have 1. So we put 1 here, and here we have 1. So we're going 1. So that's good because we have the same amount on both sides. But here we have 2 chlorine and we have 3 chlorine on this side. That's not okay to make the equation balance. So because we have 1 chlorine on this side, I'm gonna start by adding a coefficient on this. Because we have 2 and 3, it's kind of hard to just simply add whatever number there. So we're gonna just look like the first common, first multiple would be 6. So I would put 3 here because that becomes 6. But I would put a 2 here to make this 6 chlorine. So then that works out for chlorine. So we're balanced with chlorine. However, that gives us 2 iron on this side and only 1 on this side. So an easy fix to this is just to add a 2 to the iron. Now we have 2, and iron is also balanced. So that is how you balance.
For this decomposition equation, there's potassium, chlorine, and oxygen. On this side, there is 1 potassium, 1 chlorine, and 3 oxygens. On this side, there's also 1 potassium, 1 chlorine, and there is 2 oxygens. Everything is balanced except for oxygen. In order to make these balanced, you would have to get these numbers to 6 because that's the smallest common factor. So, in order to do that, you would multiply this by 3 to get 6. So you put 3 here. And then you would multiply this by 2 to get 6, and you will put 2 there. Except when you do that, these elements change, and that makes them 2. So in order for these elements to be equal to these, in order for these elements to be balanced with these elements, you would have to add 2 over here, and that makes the equation balanced. For single replacement equations, there is chlorine, sodium, and bromine. On this side of the equation, there is 2 chlorines, 1 sodium, and 1 bromine. 1 bromine. On this side, there is 1 chlorine, 1 sodium, and 2 bromines. So, let's start with chlorine. There's 2 chlorine on this side, so we have to have 2 chlorine on this side. So, you would simply add 2 here, and that would make a 2. And then there would also be two sodiums on this side, but that makes sodium unequal. So you would add 2 here, and that would also make 2 sodiums. But then that would also make 2 bromines, which makes the whole equation balanced. So for double replacement equations, there is sodium, sulfur, hydrogen, and chlorine. On this side of the equation, there are 2 sodiums, 1 sulfur, 1 hydrogen, and 1 chlorine. On this side, there is 1 sodium, 1 sulfur, 2 hydrogens, and 1 chlorine. So right off the bat, you can see that sodium and hydrogen are unbalanced. So to start off, you would make the hydrogens. So to start off, you would make the sodiums balanced by adding the 2 here, and that makes 2 sodiums, but it also makes two chlorines on this side. So the chlorines are unbalanced, so you have to balance this side too. So you would put 2 here, and that makes 2 chlorines, but it also makes 2 hydrogens, which balances out, and that would be how you balance a double replacement equation. Wow, that's amazing. I should try it out. Assistant, pass me my notebook. I can solve this easily. This is a synthesis equation. So, using penny markers, I write all the elements down. So that would be C, H, N, O. Carbon, hydrogen, oxygen. So there's 4, 6, 4, 8, is 4. So that's 4 carbon, 8 hydrogen, and 4 oxygen. And on this side, 2 carbon, 4 hydrogen, and 2 oxygen. How do I make this equal? Well, so what you can do is just add 1 to this side. And then you can tell off the bat that these numbers are multiples. No, it's factors. These numbers are factors of each other. So, if you multiply this by 2, then you would get 4 carbons, 8 hydrogens, and 4 oxygens. And that makes the equation balanced. Wow, that's amazing. And I just solved it out. So, thank you, Miss Markle. I can open my door now. Boop, boop, boop. Oh my god.
That seems pretty hard. I guess I'll whip out my handy dandy chemistry notebook. So first, we have the equation here. We have carbon, hydrogen, and oxygen. It seems like there's 2 carbons on this side of the equation, 4 hydrogens, and 2 oxygens. Then on this side, there is 1 carbon, 3 oxygens, and 2 hydrogens. So first, let's start off with 1. Wow! It's the same. So let's try putting 2 over here. And that means we have 2 carbons, 6 oxygens, and 4 hydrogens. Math is hard. So next, it seems like oxygen is not the same. So let's go over here and put that to 3. Because 3 times 2 is 6. So now, it's balanced. You can't balance your bank account, but you can balance equations. So go buy the Balance-O-Homelock 3000 now. Balance is gonna be your best friend. It'll never let you down.
Features sold separately. Batteries not included. You must be 18 years or older to order.